So when we go to install a substation, before that we plan different technical factors. Out of that, one of is your power transformer selection. On what basis we can choose the transformer, power transformer, or yes, distribution transformer for a substation. The selection of the right transformer is one of the most important decisions. The most important decisions in substation design. There are several parameters for that which have to be properly evaluated. One of those parameters are rated voltage ratio. The transformer voltage ratio must match the system voltage on both sides. It may be over 220 by 132 kV, or it may be over 132 by 33 kV, or it may be over 33 by 11 kV, or 11 by 0.433 kV. And this is considered on the basis of the system nominal voltage and future expansion. It has some certain role, and the insulation coordination requirement according to the voltage, nominal voltage. Second one is your MVA rating. The transformer rating should be selected on the basis of the load demand. The transformer MVA should be calculated, the rating of the capacity of the transformer in MVA, that is the maximum demand in megawatt divided by the power factor. The power factor is usually taken as 0.9, and this is considered on the basis of the present load and future load growth up to 10 to 20 years, emergency loading capacity if it is required of ONAN, and N1 reliability requirement on the basis of reliability requirement basis. So the present load is your 16 megawatt. This MVA calculated like this: 16 megawatt divided by power factor 0.9. This comes out to be 17.8. Hence, we may select the power transformer to the nearest standard as 20 MVA or 25 MVA. Third factor is your vector group of the transformer. Which vector group will adapt during the design? The vector group of the transformer determines the phase displacement and earthing arrangement and parallel operation compatibility. These factors are whether it is required or not. On the basis of that, we decide which vector group will be designed for the transformer. Here it is a mini table. In this table, we see this is the 33 by 11 kV distribution transformer. In that case, the transformer used, the vector group employed in the transformer is delta star N11, DYN11. Similarly, in 132 by 33 kV substation, it is YNT1. Industrial substation, same DYN11, delta star N11 normal. neutral. Similarly, your generator step of transformer. For that, we employ the vector group, that is Y capital N D1 Y or YND11. So these vector groups will, when we'll study the vector group separately in during our technical study, I can explain it in better, in detail. And then the basis of the selection of specific vector group are neutral grounding requirement. What is the neutral light grounding requirement? Harmonic separation, if it is required. On system protection philosophy, for that only we employ a specific vector group in the design of the transformer. Fourth one is of percentage impedance. The percentage impedance of the transformer depicts the fault current and voltage regulation of the transformer. The percentage impedance is calculated, that is the voltage required to circulate the full load current divided by the rated voltage into 100. This comes out to be percentage impedance. The table below displays the rated voltage of the transformer and its corresponding percentage impedance. Up to 5 MVA, the percentage impedance is 6 to 8%, and up to 10 to 25 MVA, the percentage impedance is 10 to 8 to 10%, and 52 up to 100 MVA, the percentage impedance is 10 to 12, and for up to above 400 MVA, it is taken to be 12 to 15%. The importance of the percentage impedance are determination of short circuit current, affecting parallel operation, and influencing the protection setting. These are the factors we have to take into consideration during the taking the percentage impedance. Fifth one is your cooling method. The transformer cooling method is selected on the basis of transformer loading and rating. The most common method for distribution transformer is oil natural and air natural. It bears low maintenance and suitable for moderate loading. Second one is your oil natural and air force, and this method is cooling is oil natural and air forced, ONAF, where the improvement of cooling is necessary due to higher loading of the capability. Higher loading capability, in case of higher loading capability, this cooling method is used. This is applicable up to from 10 to 100 MVA transformers. Then third one is your OFAF. This method is cooling is oil forced and air forced, OFAF, and in this cooling method oil pumps and cooling fans are used. It is suitable for large power transformer for better power dissipation. So these are the things in case of cooling method, and this table gives you the rating and types of cooling method employed up to 110 MVA. It is ONAN, oil natural air natural. 10 to 100 MVA, this is oil natural air natural, also as well as oil natural and air forced. Above 100 MVA, this is oil natural air forced and oil forced and air forced. 100 MVA, above 100 MVA. The sixth factor is your tap changer requirement. Is also it is a criteria for selecting the power transformer or a distribution transformer. The tap changers maintain the voltages within the limit. First, the tap changer requirement, different tap changer circuit are there. What off circuit tap changer, that is OCTC. In this type of tap changer, the transformer is de-energized, totally de-energized, and it is low cost and used in distribution transformer. In case of on-load tap changers, OLTC, in this type of tap changer, the voltage adjustment is made without any power interruption and is essential for power transmission and grid substation. The automation voltage control is possible. The typical OLTC ranges from plus or minus 5%, plus or minus 10%, and plus or minus 12.5%. It is usually available in 17 or 19 steps. In conclusion, we have to say that during the selection of the finalizing the transformer selection, the recommended data we should have the system voltage, maximum demand, and future load growth, fault level in kiloampere, earthing system, reliability requirement, ambient temperature, then indoor outdoor installation. It should be given. It is the input data, input design data, voltage regulation requirement, utility standard as per Central Electric Authority, Indian Standard or International Electric Code. The properly selected transformer should satisfy the present load demand, future expansion, fault level requirement, voltage regulation, and reliability criteria, while remaining economical throughout its service life. So, if we follow this method, these steps while selecting the power transformer, will remain economical throughout our service life. That means the substation will be most economical if we proceed in proper manner. This is for today. Thank you.